Chapter 23 extends the discussion on volatility, and as we've seen, sigma, the volatility of the assumed prices, plays a fundamental role both in our binomial process modeling, but also in the Black-Scholes model itself. It's fundamental to all of option pricing, and Chapter 23, which we'll look at in 2 modules, it's a relatively short chapter, but presents some key ideas on this notion of volatility. First one is implied volatility, which is a topic that's come up before. Implied volatility is the volatility needed in an option pricing formula in order to reproduce the price observed in the market. Typically, people use the Black-Scholes formula in order to do this. So sometimes people call it the reverse engineering of price. In other words, the Black-Scholes formula, almost virtually all of the variables in the Black-Scholes formula are observable at a given point in time other than sigma. So if you can observe a price of an option, since all the parameters in the Black-Scholes formula are observable, you can observe them and plug them into your version of the Black-Scholes formula and then determine what sigma value will reproduce the market price. That's the process of reverse engineering price, and that's the process of determining the implied volatility in an option. You can also look at historical stock data. And I've talked about this in prior modules, where when you're trying to price an option, you need a sigma that's a prospective measure of stock price volatility. Historical analysis, or analysis of historical prices, is valuable for this purpose, but obviously it cannot give you a unique answer that you can be confident in. What it can do is apprise the market maker of the range of volatilities that have been observed in various periods in the past, and that might inform the market maker as to what might be a conservative estimate or a reasonable estimate of sigma in the future. Implied volatility is actually an observation, at least on someone else's estimate of what sigma ought to be, and that it's an estimate that that other market maker that's selling that option is confident enough that they're actually putting their capital at risk for. So the implied volatility, as I said, one uses Black-Scholes as the most common way of doing it, because it's an easy program it's an easy formula to program, and using Solver and Excel or a variety of mathematical software tools, it's pretty easy to numerically estimate the sigma that reproduces the market price.